Hello and welcome to Code at Home, episode 16, where we're going to be talking about recursion. My name's DJ, and if you look below me here, there's a bit.ly Code at Home URL that you can follow, especially for the parents or guardians, and that will lead you just to find out a little bit more about this series and what we've been doing and what we're going to be doing and everything, and a little bit about me as well if you're curious and just want to make sure everything's okay. There's a blog post that I wrote with just general high-level details of this series and a bit about me and bits and pieces like that. Just for those who have been joining these episodes over the last few weeks, first of all, welcome back. Super warm welcome back. And also to people joining for the first time, a super warm welcome for the first time as well. I've been streaming regularly, doing a live stream on Mondays, Wednesdays and Fridays, always at 3:30 in the afternoon in UK. However, I'm just reducing this now due to workload. Work is increasing for me, so I can only do Mondays and Fridays at the same time. So basically, the Wednesday afternoon slot disappears. So I've just updated the blog post there. As usual, you can find all the previous episodes here on this link here. If I go there, you can see it explains how to get to those episodes on YouTube. But there's also links here. And the last one we did on, what day is it? Friday. On Wednesday was episode 15, where we continue to do some refactoring to improve our code for the double base palindromic numbers solution. We're almost at the end of looking at that. This is something we just want to finish off from last time, so we'll do that first. And then we can get on to the main business of the day, which is to start looking at recursion. Recursion is a wonderful thing. It's a very curious thing as well. And it's something that took me a little bit of time to sort of get my head around. So we're going to approach it in a really simple and slow way together. And if we need to, we can continue with it on Monday. But anyway, before we start with just finishing off from last Wednesday, I just wanted to give you an idea, one example of recursion. Well, let's first of all go to the Wikipedia article on recursion. In fact, you can show your friends this. If you go to Google, I'm just going to open up a new tab here. And if you Google for recursion, just recursion, can you spot the wonderful little so-called Easter egg, a little surprise, a little secret? We've asked for recursion. And sometimes when you type a search query into Google and you misspell it, or you type it wrong in a different way, Google will say, due to its vast knowledge, oh, did you mean this? Here, we type in recursion and Google says, did you mean recursion? So you click that and we go to recursion. Did you mean recursion? Click over and over again. We're recursing, going back on ourselves. And here we can actually see, I'll just make that a little bit bigger, we can actually see that the definition here is a little bit hard to get our head around, so let's not even bother with that. Instead, let's go back to the Wikipedia article. And rather than look at the text for now, I just want to show you a picture first of all, so the picture is in our mind. And I'm sure you've seen, or you might have seen, similar sorts of things on adverts maybe, or on stuff that's around the house. So here is a beautiful old container. It's a tin, an old tin that used to have cocoa powder in it to make nice hot cocoa drinks. And if we have a look at it and zoom in, okay, so there's the picture that somebody's taken with a camera of the tin. And what's on the tin? Well, the brand of cocoa powder, Drost or Droster, I'm not quite sure how to pronounce it. Drost, I suppose, because it's Poids-net, it's French, isn't it? So yeah, 500 grams. Now, On the tin, the red tin, we've got the word drost, and we've got a lady here, and she's holding a tray. On the tray is a nice warm cup of cocoa, but next to that cup is a tin of drost cocoa. So if we were able to zoom in on that tin of cocoa, we would see that it's got drost on the tin, it's got the lady, and she's holding a tray with a cup. Next to the cup is a tin of drost cocoa. If we were to zoom into that, even smaller, we'd see that on the tin, got the drost, the lady with the tray, the cup, the tin of cocoa. On that tin of cocoa, there's drost. It's a cup on a tray, and next to it is a tin with a picture of the lady, etc., going in and in and in and in and in. Recursing. So this is like a recursive image. So let's just have that in our mind and let the power of our background thinking come in. And now we're just going to completely forget recursion for now. Or stop talking about it, not forget it, but stop talking about it. And we'll get back to where we left off on Wednesday, and let's complete this other little task that we would started. Okay. So why don't we remind ourselves of where we left off? So we were in the Code at Home 15 REPL on Replit. So you can go to Replit at QMacro Code at Home 15. If you were there with us on Wednesday, you might already have that ready. So well done. If not, don't worry. We're just going to finish a few things off. You can just watch, or you can go here and make a copy. I've just noticed that Replit, the website, has just slightly updated because there's one big sort of play button now, run button. It just looks slightly different. But anyway, that's really cool. That's cool. So where had we got to? Well, what had we done? As you can see, we sort of commented out our solution here. Let me just uncomment out or uncomment that. Let's just hold down Control and press /. So we've got this line, which we'll look at in a minute. And then we've got this line, which is our solution really to the double base palindrome problem. And now if we run it, we should see the output of that console.log statement, which goes and generates a range of numbers from 1 all the way through to 9999999, checks whether both the decimal version and the binary version are palindromic, gets all those numbers, and then adds them together using our powerful reduce approach using the add function. So the question is, where is this add function? Where is this are both palindromic function? Where is this range function? Well, we're bringing them in from our super utility library that we created on Wednesday, remember? So we're requiring that library, utils. So there's a file called utils.js. Where is it? Well, there it is there. It's just living next to the index.js. And that's where we've squirreled away all our super useful functions. Okay, so we can sort of forget them and not worry about them. I don't mean forget them, but not worry about them. Okay, let's go back into the index and close this little files container again. So that's what we had done. So we've got our solution. The solution is still correct, 872,187. But what we'd said was, well, the range function, if we're going to write a range function for ourselves in JavaScript, we might as well write it so that it acts in the same way as the range function in Python. And if you remember from Wednesday, or if you've seen the recording of Wednesday's live stream, you'll remember that the Python range function, as in the range function in the Python language, Python 3 specifically, if you're interested, you can call it in two different ways. Or it was described in two different ways. In fact, there, let's have a look at it. Rather than me try and describe it to you, let's have a look at it. Where's it gone? Where's it gone? There. Class range. Don't worry about the word class. We can either call range with a single value, and that will be interpreted as the stop, as in start, stop, or from and to. Or we can supply more than one parameter, in which case we can either supply 2, which will be interpreted as the first one being start, and the second one being stop, as in from 1, let's say, to 10. And if we're doing it in this format here with multiple parameters, we can add a third possible parameter, which is going to be a step, as in by how much to increment to counter each time. Okay, so that's what we're doing. We're implementing a more Pythonic or Pythonesque, Python-like range function. And this is how far we've got. We're just defining the function here as a constant, and just for now, we're just calling it prange to remind us it's the Python style range function. Okay. And you remember, I think this is the first time we saw it on Wednesday. We used this rest operator. Well, sorry, I've just highlighted all of it. This thing here is the rest operator. So if you prefix a parameter name in this context with ... it basically means however many parameters are passed, I want to capture them all, whether it's 0, whether it's 1, 2, 3, 10, 100 parameters. I want to capture them all, and I want them all to be captured in an array called params. So let's just remind ourselves that that's the case. And I'm just going to return. Let's return 42. Doesn't really matter what we return, right? So all I've done here, just to show ourselves what's happening here. In fact, rather than do that, that's a bit silly. Let me just comment these lines out for now. There we go. So all we're going to do, just to see what this rest operator does, if I say prange and don't pass it anything, call the function, don't give it any parameters, it's going to give us params as an array, but that array is going to be empty. Obvious. If I pass it a single parameter, it's going to give me that single parameter as the only element in that array. If I pass I don't know how many I passed there, it's going to give us all those parameters as elements in an array called params. Okay, so that's what this rest operator does. Okay, so we can now get rid of this line. We can bring these lines back to life with, again, Control/. Okay, so now we can carry on. And where we'd left off, we'd said, okay, well, the way we've defined our range function originally, we can use most of that again. Let's remind ourselves of what our original range function does, how it generates that range of numbers. And there's no surprises. We've done this before, haven't we, together? Let's have a look in our utils file. There it is there, const range. Let's copy that. You don't have to copy it, don't worry, you don't have to copy it. I'll just copy it so we've got it in here as a reference. Let's put it above here. And also let's comment it out so we know that we're not going to use it. Okay. So this stuff here, we're going to reuse this approach. Start with an empty array when we're generating the elements of our range. Let's say we're going to ask it for a range of numbers from 1 to 10. We want an array with 1, 2, 3, 4, 5, blah, 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 10. So the way that we do that is we start with an empty array called result. And we use a for loop, of course. And why don't we use the variable I as a little increment counter? And we go from whatever is in from, in that case there, we've called it start here now. Okay. And we go all the way up to and including, in this case, 2, or in this case, stop. But remember, in Python, we saw it, didn't we, on Wednesday? Python's behavior is that it will give you all the numbers up until but not including stop. So if we say range 1, 10 in Python, it'll give us the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9, but not 10. Okay, so we've got to be careful when we do that here. And of course, the step, got a step parameter as well. Now here, we'd fix the step value to 1, a literal 1. So okay, we've got to watch that as well. Okay, so given that that's what we're going to do, let's move that over there so we can see that on one line. What we started to do is to say, well, okay, we're going to be, assigning values to 3 variables: start, stop, and step, or from, to, and step. Let's use start and stop. Quite like those. So then we say, well, how many parameters have been passed? Have we only been given one parameter? As in, is it the circumstance where it's being called like this, where we just pass one parameter, in which case whatever's passed is the stop value? Remember that parameters is an array, so we have this length property on that array that we can access. And we say, if this condition is true, as in the length value of the params array is 1, then what we want to do is we want to assign the following values: 0, and the first element, or 0th element of the params, as in the only element in there, and the literal 1, to the value, to the variables start, stop, and step. And do you remember what we called this technique, using the square brackets here on the left-hand side of an equals, an assignment equals operator? Do you remember what that word was? We talked about it a little bit. That word is, or that approach, that technique is called destructuring. Basically, we're building up an array, a literal array of the literal value 0 and whatever is the 0th element of params, and then a literal value 1, and we're just plopping those into start, stop, and step, respectively. So why don't we run this now and let's see what happens. Let's run that. This is where we left off. If we say prange 10, for example, calling it just like we'd call it, we'd call it here, range with a single value. This here in the orange is the output of this console.log function call. We're passing it start and stop and step. So start is 0, stop is 10, and step is 1. And is that correct? Is that what we want? I think it is. Start is 0. Stop is 10, yes, because in params, which is an array, we've got whatever was passed as a parameter, which is the value 10. So 10's in there as the 0th element. So stop is 10. And then step is 1, because we've said, well, that literal 1 there goes into step. Great. So now let's deal with the situation where 2 parameters are passed. And you can almost guess what we're going to write. And you can write this as well. This is what you should be writing. And we'll write it out manually rather than cut and paste. I quite like to do that because you get the feel of the language under your fingertips. If params.length, it's going to be just the same here, equals, that's a strict equals 2, as in if the number of parameters passed when prange is called is 2, then, and this is always going to be the same as well, start, stop, step equals, okay, I'll give you time to catch up with typing that. I mean, if you want to cut and copy paste it, you can copy paste it, it's no problem. Well, what do you think it's going to be? Remember that if we look at the case where range is called with 2 parameters, don't forget that these square brackets, in this sort of style of documentation where it shows you what the possible calls could be, if you have something like that in a square bracket, it often means This bit in the square brackets is optional. Okay, you can do that bit or you don't have to do that bit. So we're dealing with the stage where we're just going to have these two parameters passed. Two parameters passed, start, which we should interpret as start and stop. So start is going to be whatever we pass as the first parameter, as in the 0th element of the params array. Stop is going to be the next one, and then step is going to be 1. Okay. Now, we can do it like that, and that's really nice and clear. Actually, I'm going to add a line. You don't have to add this line if you don't want to. I'm going to add the same line. I'm going to comment it out in a minute, but a different way of doing that, this bit, and it's actually, no, it's potentially confusing, so I'm not going to do it. I'm not going to do it, no. For those watching who are wondering what I was going to do, I was going to show the other side of the coin to the rest operator, which is the spread operator, which is exactly the same, ... but does something different. No, I'm not going to do that. Okay, let's carry on. Now we need to deal with the situation if three parameters are passed. And of course, if three parameters are passed, we're going to interpret them as the first one being start, the second one being stop, and the third one being step. So start, stop, step. Okay. And now all we have to give it is, well, whatever's in the params array, because there's an equal number of elements in the params array in this particular circumstance, 3, that we can then have assigned to there. We can destructure into start, stop, and step. So that's nice, isn't it? Params. Okay, so shall we try that out? Let's run it to have the pRange function redefined. If we say pRange, let's keep it as 10 for now, pRange 10. Same as before, start is 0. We default to starting at 0. Stop is 10, and the step is 1. We can say go from, I want a range from 0 to 20, for example. Great. 0, explicitly this time, 20, and again the step is 1. I could say, oh, actually, no, I want to go from 1 to 20. There we go, 1, 20 in step of 1. But in fact, I want to go from 1 to 20 with increments of 5, in steps of 5. There we go, 1, 20, and 5. So it's all good. Okay, so we've now written a little function, or the start of a function, that can deal with different ways that that function could be called. So now all we have to do is do something similar here. Let's get rid of this console.log statement and say const result equals like that, just like up here. And then we need our for loop, don't we? In fact, let me just get rid of that empty line there, so it just moved up a bit. And now all we have to do is the for loop. So for let I equals, now let I equals where we start. Where are we starting from? We're starting from whatever is in the start variable. I equals start. Where are we going up to? We're going up to stop, but just before stop, not to stop exactly, not to all the way to 10 if we specify 10, but to 9, 10 minus 1. So we say as long as I is less than stop, not less than or equal to, because of course that then would make sure that the stop value was included in the range, but we don't want it included in the range. So we want as long as I is less than stop, and then each time around the loop, how do we make I bigger? How do we increment I? Well, I equals I plus, You guessed it, step. So it's very, very similar to this, isn't it? And of course, all we have to do now is onto the result array constant, we can just push whatever I is, and that's it. And right at the end, as the output of that function, we just return whatever is in result, which is going to be an array with maybe some numbers in it. So that's quite nice. Let's try that. P range 10. Now, what do you think he's going to give us? Shall we find out? Let's move this across here a little bit. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because the default start is 0. There. We're going all the way, but not quite up to 10, which is 9. And we're stepping by 1. Let's try saying, well, I want to start at 1, for example. And we're going to use the option to give 2 parameters. There we go. We get 1, 2, 3, 4, 5, 6, 7, 8, 9, but not 0. And let's say now we want to increment by, well, let's increment by, I don't know, 3. 1, 4, 7. But not 10, of course, because we're not going right up to 10. We're going just before 10, as near to 10 as we can get with that increment. So there we go. We've written now a new version of our range function called prange that works a lot more like the Python's range. So then it's easier in your brain to switch between different languages. Okay, perfect. Have you all got that? Let me just make that a little bit smaller over here in the REPL so we can read it in one go. Okay, and of course, after this, you can always go to the code at Home.16 and copy that. Let's clean up this. We don't need this bit that I brought in just for reference, do we? There we go. In fact, why don't we? I'm going to Control X, which means cut. Bring that into utils, and we'll replace, you can do this later if you want, and replace it. So that is our default range function now. So I've got rid of the old range function. Okay. So now if we bring this back in, are we going to get the same answer? Let's see. $872,187. Great. It just so happens actually that we should really have said 1 million, because of course we know that we want to go up until but not including 1 million, which is what our range function now does for us. So I think we should leave it at that, because that's the more correct request, isn't it? Okay. So let's now go and change subject completely to recursion. Let's close that. Let's open up a new REPL so we can just start playing around. So you can do this as well. Open up a new REPL. So either click the new REPL button there, or you can go back to REPLit's home and click the new REPL button. Again, let's go down and find, where is it? JavaScript. Giddy Agile Astronomy. I quite like that name, but we'll call it, surprise, surprise, code at Home.16. Again, so you can find them easily afterwards. So let's create that REPL. Okay. Almost there. Now, how do we start? Well, let's go back. Wikipedia to the Wikipedia Recursion page. And let's just read together what this first bit says. Okay? Recursion. Recursion occurs when a thing is defined in terms of itself or of its type. What's that mean? Well, let's jump down. The most common application of recursion is in mathematics and computer science. Oh, look at that. That's a nice... Can anybody tell me, or can anybody shout out to yourself, I suppose, what that symbol is there? It's just chopped off at the top and chopped off at the bottom. But the name for that symbol we've actually used in previous Code at Home episodes for an anonymous function. I'll give you a clue. It's a Greek letter. Anyway, the most common application of recursion is in mathematics and computer science, where a function, and we know what a function is, being defined is applied within its own definition. Basically, recursion, as far as we're concerned, and as far as what we're going to do to just sort of have the first feel for what recursion is and what it feels like, we're going to define a function that calls itself. Why would we do that? Well, hopefully we'll find out. It's almost like this little tin, this cocoa tin. This cocoa tin has itself on its cover. And even the thing that's on its cover has itself on its cover, which has itself on its cover, which has itself on its cover, and so on. Okay? It's a little bit of a strange thing to grasp, recursion. And recursion is basically used as an approach to coding certain things in certain ways. In some languages, recursion is used more than in other languages. So, for example, there's a very venerable language called Lisp, L-I-S-P. And recursion is used a lot in Lisp. Recursion is used effectively to do things that repeat, that iterate, that go round and round, over and over again. Okay, we've been doing that manually, as it were, using a for loop. Okay, but some languages don't have for loops. Some languages don't have loops at all. Strange, but true. And in those languages, recursion is one way of bringing about some function that does something multiple times. A function that does something and calls itself. Okay? But you might think, and there's actually a word here that's just caught my eye, a phrase, you might think that if a function calls itself, and then to start things off, you call that function, well, that function is going to do something and call itself, call itself, call itself, call itself, call itself. My wrist is making a noise. Call itself forever. It's never going to finish. It's going to be in an infinite loop. Okay, so when we write a function that calls itself, we've got to make sure that that function has a way out. Okay, that function can say, whoa, okay, that's enough. That's enough. You don't need to call. I don't need to call myself anymore. Stop. And quite often that's called the base case. Okay, but anyway, that's enough talk. Let's close that. Now, if we have, and you can type as well with me, if we have a list of numbers, our range function would be useful here, wouldn't it? But we'll just create a list of numbers for now. 1, 2, 3. That'll do, actually. 1, 2, and 3. 1, What am I talking about? Const nums equals 1, 2, 3. There we go. How would we add those together? Well, we could say, for example, and let's put this in a console.log statement and, have some nice spaces in between. Okay, so whatever we put in here in lines 4, 5, and 6, when we run it, it'll be printed out to the console, of course. So how would we add these numbers together? Well, one way, a bit of a silly way, would be to do this. Nums, the 0th element in nums, plus the first element in nums, which is 2, of course, plus, nums, plus that element of nums. Okay, shall we try it? We all know what 1 plus 2 plus 3 is. 6, isn't it? 1 plus 2 is 3, plus 3 is 6. And there we go, we get 6. But what's wrong with that solution? It works, but there's lots of things wrong with it. It's a lot of typing. It only works as well when we know that there are exactly 3 elements in the nums array. We can do better, can't we? And of course we can do better. Remember, we're needing even more of these utility functions now, but let's write it out again so we got them here as well. Add is a function that takes 2 parameters and returns their sum. Okay, just like we've had before. And you can guess what I'm going to do now, can't you? Nums.reduce, add, and the starting value for the accumulator in the reduce mechanism should be 0. 6. Remember? Let me know via the email, qmacro plus, where is it? Let's go back here, go there. Get your parent or guardian to email me if you want to do more on reduce, if we still need to look at reduce, or send me some feedback as well. Okay, because I know that reduce, sometimes takes a bit of a while to get into your head, but it's a really, really, really cool function. Okay, so that's a better way. That's a really nice way of adding a load of numbers, because of course, if we add more elements to the nums array, it'll still work. 1 plus 2 plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21. Yeah, it works. So that's great. Now, one of the things with coding, with programming, is that there's lots of different ways of doing things, and there's lots of different styles, and you might have a preferred style of programming. You might use a style that fits in with the way that your friends or colleagues are writing if you're building something together. There's all sorts of different styles and approaches and techniques, and there's all sorts of different reasons for using those styles and those approaches and techniques and choosing which one for any given circumstance. So remember that what we're going to look at now, recursion, is another way. For example, here in this super simple example that we're going to be doing is another way of adding numbers together. It's not better than using a reduce. It's not worse than using a reduce. It's just a different way. And it's a really nice way for us to introduce our brains to the wonderful magic. Well, it's not really magic, but the wonderful nature of recursion. So, when we looked at the definition, we saw that recursion, when it comes to mathematics or computer science, is usually defined in the context of a function definition. So let's define a function. Let's get rid of this line for now and start defining a function just here. Okay. Let's comment that one out because we're not going to use that helper function anymore. And just to distinguish it, it doesn't really matter, but just to distinguish, let's call this recursive function sum. What is the sum of the given set of numbers, of an array of numbers? Const sum. So we're defining a constant, sum, and that constant is, through the assignment operator, equals there, is a function that takes, what we're going to call it, some numbers, or let's call them values. Again, what is the biggest challenge we've had all the way through this series so far? Just thinking of names for things. Okay, so it takes a single parameter, vals. Okay. And that single parameter we're going to expect to be an array. So we would pass, for example, some nums or some 1, 2, 3, 4, 5, like that. Okay, so we're passing an array as a single thing, because that, yes, it's got five different elements in it, but it itself is a single thing. So we're passing a single value, that array, it's going to be captured in vals. Okay, so far so good. Let's get rid of that. Now, this is not going to be a single expression function, so of course let's use the open curly brackets to create this block that we can type some code in. Have some water. Now, there's some wonderful concepts from Lisp, which is where recursion is used a lot. And we're going to use a couple of those concepts. The idea that when you've got a list, well, when you've got a list like nums, you can see, or you should look at that list in two parts. The start of the list and the rest of the list. Sounds a bit strange. The start of the list is a single element. So the start of this list is the value 1, that first single element. And the rest of the list is just the rest of the list without that first element, okay? The start and the rest. Or some people like to use the words the head and the tail, which is quite nice. I like that. The head of the list and the tail of the list. Or the first and the rest. You know, you get the idea. Okay? So this is a concept that's going to help us when we start to think about how we want to work through the list of numbers to add them all together. So given that, why don't we first of all just get a feel for how we might get hold of the head, or the head. Let's use head and tail. Yeah, first and rest, or head and tail. How we might get hold of the first element, and how we might get hold of the rest of them. Okay, now, of course, that's one way of getting hold of the first element each time, isn't it? Tail equals, how do we get hold of all but the first one? Well, one way is to use a function called slice. And the slice function returns a shallow copy of a portion of an array into a new array object, which is quite nice, selected from begin to end. So let's try that out. If we say here, nums.slice, I don't know, I'm just going to put a random number in, like 3. Wow, what's that done? That's given us a slice of the array. There's 0, the 0th element. There's the first, second, third. Starting from the element with the index 3. And then because we haven't specified how many we want, it's just going to give us the rest of them. We could say, for example, here, num slice 3 just for 1. We don't get any, just for 2. It's not how many begin and end. It's not begin and length, is it? Sorry, begin and end. So we can say 3 all the way up to 5. We get 4 and 5. But if we say 3 all the way up to 6, we get 4, 5, 6. So to get everything but the first element, we can just say nums.slice of 1. Just chop it. There. Dot slice 1. And let's just print these out. Console.log head. In fact, let's print them on separate lines. Okay. Let's try that first of all. Oh, we haven't called sum yet, have we? Sum. Oh, console.log sum nums. Okay. Yeah, why not? Let's get rid of that space as well. In fact, let's not be fancy. Let's just put it all on one line. There we go. Right. There we go. So all we've done is we're defining this. Let's get rid of this line as well. We don't need that either. We're now defining our nums constant, and that's just an array of 6 numbers. We've defined our sum function that takes a single parameter, which is going to be an array, and grabs the head and grabs the tail and just prints them out. And then we call that function, okay, so we can see what's going on. So when I press Control Enter, it'll just show us. So there we go. We can see we've got the head there, 1, and we've got the tail, 2, 3, 4, 5, 6. And the important thing to know is that the head is always a scalar, as in it's not an array, it's a single value. So it's not 1 inside an array, it's a single value. And the tail, or the rest of it, is just the rest of the array. 2, 3, 4, 5, 6. Of course, it's going to be an array, right? Now, that's a quite nice way of grabbing the head and the tail. But I want to introduce you to a different way, using a technique we've seen just before. So what I'll do is, my cursor's here, again, I can hold down Shift, press the up arrow, so that both lines have got some highlighting on them. Look, there's a little bit of blue there, and there's blue there. And then I can hit Control and /, and I've commented those 2 lines out. Okay, we'll leave those there for reference. Now remember in the previous Replit, code at Home 15, we used the rest operator to grab however many parameters were past that function. ... params, didn't we? Now, why do you think it's called the rest operator? Let me just type something out and we'll explain it. Const x and then ... x's equals vals. Whoa, what does that mean? Well, let's just pull it apart and understand it. First of all, I'm going to use that word again, destructuring. So what we're doing here is we're saying, right, and we know that vals is an array, right? We've got this array, vals. I want to pull out values from that. I want to pull out elements of that vals array. Okay, we can see that intent because we've got these square brackets on the left-hand side of this assignment here. Okay, so we're doing some destructuring. And what are we saying inside there? We're saying, first of all, I want a single value, and I want to assign it to x. I want a single element, the first element, because x is first there. And then I'm using the rest operator to say, and I want to put the rest in another constant called x's, okay? Remember, I think we talked about this very early on. In many cases, I use x for that thing, that variable, that thing. So it stands to reason, in my mind at least, that if there's more than one thing, it's not x, it's x's. Okay, so x's is like, in my mind, a plural of x, more than one thing. Okay, that's not my invention. I think it's wonderful. It's not my invention though. It's the idea came from a wonderful programmer called Eric Meyer, who I've learned so much from. So what we're saying here is, I want to destructure whatever's it. I want to destructure the vowels into a single scalar value and put that in x, and whatever's left, I want to put into x's, xs, right? Let's just see that in action first of all. Oh, hold on. There's x and x's. I've just realized I've got head and tail here. Let's use head and tail. Okay, so it's like the same as before. What a fool. What a fool I am. Okay, so head and tail. I want to grab the first element and put it in head, and I want to grab the rest of them, whatever's left, and put them in tail. Let's try that. See if that produces the same thing. It should do. There we go. And maybe we now get an insight as to why this operator is called the rest operator. Because it just gobbles up whatever's left. The rest. Give me the rest. Put the rest in there. And in fact, we can see this in action a little bit more even. Let's say we wanted to grab the first element, put it in head, and then we also specifically wanted the second element in another constant called second. Whatever was left after that, after grabbing the first one and the second one, then whatever's left, the rest, goes into tail. So let's now say console.log second as well. Just have a look and run it. There we go. So 1 gets destructured out of vowels and into head. 2, the second element, gets destructured out of vowels and put into second. Then the rest end up in tail as an array. So that's a really cool way of grabbing the head and the tail of an array. So we'll use that technique, okay? Head, we don't need second, of course. Head and tail. Now, here comes the bit that's going to blow our minds a little bit. What? So let me get rid of these two things here. And I'll leave the console.log statements in there for now. Okay, fine. So what do we need to return? What value do we need to give back from this sum function when we call it with a list of numbers, with an array of numbers? How do we add them all together? Well, we return whatever the answer to adding the head to the sum of the rest. What? Now I know, if you're like me, this will take some time to sink in. There's one bit we haven't done yet in this function, just in case you're wondering. But let's just, in the last 5 minutes, dwell on that. So, in fact, let's just get rid of these console statements for now because it's cluttering things up. There we go. So, are you still with me? I think I'm still there, am I? Yes, am I on the live stream? Yes, okay, good. Just got a strange message from Lightstream. So, what is head plus the sum of rest? Well, we know in this particular circumstance, when we call it with nums, head is going to be 1, okay? In fact, let's reduce this back down to a really simple list of 3 values, okay? Let's put some spaces in there to make it look nice. There we go. Ooh. I'm trying to make it look nice and make it look horrible. There we go. That's better. Right. So when we call sum, let's write it out here. When we call sum and pass it 1, 2, 3, oops, like that, what it's going to do is it's going to return head, which is 1, plus the sum of the rest. So how is that going to sort of resolve itself? Well, JavaScript is going to say 1 plus, oh, and I've got to call a function to get the other side of the plus sign. I'll call the function. I'll call myself. Or some says I'll call myself. So I'm going to, can I press Shift Enter? No. So then, let's do that like that. So then it becomes, in fact, I can do this better. I can illustrate this better in the editor. What will happen when we call sum nums, let's put this in all in comments here. There we go. That's better. Right. Now I can sort of write things out. When we call sum nums, what's going to happen is it's going to say return head, which is 1, plus the sum of the rest, which is 2, 3. Okay, so how does that resolve? Well, it resolves into calling 1 plus, because that's the same as before, 2 plus the sum of the rest, which is in that case 3. Which resolves into 1 plus 2 plus 3 plus the sum of the rest. And after you take 3 out of an array with that's just got 3 in it, as for the head, what's the rest? Nothing. Okay, so what's going to happen here? Then we call 1 plus 2 plus 3 plus... Okay. We need now some way of saying, whoa, that's enough. Whoa. We need our base case. So let's add one more line to our recursive sum function here to check for the base case where sum is given an array with no values in it. Okay. If vals.length, we know how that works, don't we? If the value of the length property of the vals array is 0, as in if you're given an array with nothing in it, which will be the case when we get to here, then just return nothing, or rather return 0, because 0 is not going to affect the addition, is it? Okay. With addition, 0 is a special value because when you include it in addition, it doesn't affect everything else. It's a bit like 1 with multiplication. If you times like 3 by 4, and then you get 12, of course, and then times it by 1, you get 12. Times it by 1, you get 12. Times it by... So timesing it, multiplying something by 1 doesn't really have any effect. Adding 0 to something doesn't have any effect, effectively. So here is our base case. So let's just put it on a line of its own there. So that means then that when we get a call to sum of empty array, this return statement kicks in and returns 0. Okay, and then we end up winding all the way back up. So all then the REPL's got to do is add up, well, 0 plus 3 plus 2 plus 1 is 6. How crazy is that? Let's just see if it works. Because right at the top of the hour. Let's run it. Oh, rest is not defined. What? Oh, tail, not rest. Tail. We decided to call it tail, didn't we? There we go. Sorry. 6. And let's just double check. Let's add those other numbers back to the nums. What was it? 4, 5, and 6. And now add up to 21, don't they? Let's run that. 21. Okay. Now, I'll remove those again, because then you can sort of go through it. And this bit in comments here will make sense from 1, 2, 3. And that's it. We've had an hour. We've just managed to start scraping the surface of this wonderful thing called recursion. Okay. Thank you so much for joining. Have a great weekend. Stay home, stay safe, wash your hands. And I'll see you on Monday for more recursion, I think. Bye for now.